Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello and welcome to another episode of GOTO Unscripted. My name is Bert Jan Schrijver, I'm CTO at OpenValue. And I'm here at GOTO Amsterdam together with Alina Yurenko.
Hi everyone, my name is Alina and I work as developer advocate for GraalVM at Oracle Labs.
So let's talk about GraalVM then, Alina. What is GraalVM? Can you explain it in maybe 10 sentences?
10 sentences. Okay, that will be challenging because GraalVM is so many things and in a way it's a nice challenge to have, right? But also then it makes it kind of hard to explain it to people what is it. But I would divide it into three parts. So one is GraalVM is a high performance JDK. So it's a JDK like any other JDK you might be using, like OpenJDK. It has the same hotspot VM, but we replace the compiler with our own Graal compiler. So that's one part of the story, is that you can use it as a JDK to run your applications with the Java command as you normally do. Then there is another big part of the story, and that is native image, and that is this ahead of time compilation of Java applications that produces native executables that can run without a JVM. So that is also GraalVM. And the last but not least, people also call it a polyglot VM because in addition to Java and all those traditional JVM languages, Scala, Kotlin, it can also run JavaScript, Python, or even your own custom language. So three things, but in a nutshell, it's a high performance virtual machine for many languages.
Okay, well, so I've been doing Java development for a while. I know where I can get my JDK or JVM. Why should I use GraalVM instead of another VM?
There can be so many reasons why you could be using GraalVM instead of any other VM. So one thing is that you can use it as a JDK, right? So just run your code on a JVM with just-in-time compilation. And the reason to do so is that some workloads, many of them, will see speed up just by switching to GraalVM as a JDK because we have this new compiler that cannot give you a specific number for the speed up that any random application in the world will see because it highly depends on what the application does, what dependencies it's using, how it's written, etc. But I do recommend always at least check out GraalVM as a JDK. So that's one reason to use it over any other JDK. But I think area where we see a lot of interest is native image and the way to build your Java applications as native executable that no longer need JVM to run. And the reason to do so, I mean, sometimes people ask us, but why give up JVM? Because it gives us so many benefits, and it does. But also it's just another way to deploy and build your Java applications. So maybe if you care a bit more about startup, about memory usage, about these kind of things, then native image would be a way to go. Yeah.
Well, I have a lot of questions about native images.
I had no doubt.
First, let's dive into the VM part a bit. So could you say that it's a drop-in replacement for any VM where I'm running my current Java code on?
Absolutely. So migration there is very easy. You just replace your JDK with GraalVM, you point your Java home to GraalVM distribution, and you run the applications as is. So you have all your libraries, tools, IDs, etc. available to you. There are some minor limitations. I think most users would not necessarily notice them, but for example, like implementing additional GC on a new compiler is not easy because there is this connection between the compiler and the GC. Mm-hmm. So maybe if you want to use some custom GC, that will be not trivial. But other than that, I would say 99.9% users can easily migrate in a matter of minutes to GraalVM.
And you mentioned that, you probably noticed performance improvements, right? You also mentioned JIT, the just-in-time compilation. So are those improvements coming from a better JIT and optimization, or why is GraalVM faster than an average JDK?
I like how you said the GraalVM is faster than the average JDK. I mean, I do agree, but notice that I did not say that you said that, so thank you for that.
I'm just making it up for you.
Yeah, I appreciate it. So those speedups are coming from the compiler itself, indeed, because the only thing we are replacing in hotspot VM, if we are operating in this just-in-time compilation mode, is the compiler. But the compiler is very good. It's brand new. It has tons of optimizations that are implemented in it from scratch. And because of all those reasons and because of those aggressive optimizations, we see many applications and many workloads running faster on GraalVM even as JIT. So I think one of the latest such stories, or at least that I can recall, is from Facebook. And they moved some of, I think it was data-intensive apps to GraalVM. And they saw something like, I think, 10% of speed up just by switching to GraalVM. So it didn't do native image, didn't do any of that, just switched to GraalVM as a JDK. Okay,
interesting. I think you also read or heard somewhere that you can also use GraalVM in an Oracle database. Am I correct, or did I get fooled somewhere?
No, that's very true. And I like this question because I don't get asked about it a lot. So as you mentioned, you have a lot of questions about native image, and people usually have a lot of questions about native image. But this use case in an Oracle database is so cool. So the way it works is that we have kind of an embedding of GraalVM in Oracle database. And it can execute other languages. So the languages that we call GraalVM languages, the ones implemented on top of GraalVM. And at the moment, I think the only one available is JavaScript. So you can execute that right in database. So you don't need to kind of extract your data, move it somewhere, process it, put it back. And another benefit is that you can leverage the ecosystem of all those, millions of packages that are available in the JavaScript ecosystem. And you can execute that right in your JavaScript, in your database. Yeah. So for example, maybe you want to validate some, email, that it's indeed a valid email, and you can use whatever the JavaScript library is being used for that. And the part that I really like is that it's a kind of project that shows the kind of value of GraalVM as an ecosystem. Because in this case, for example, it's an implementation of JavaScript. So the JavaScript component on GraalVM, and then it's built on top of Truffle, which is our language implementation framework. And the way it is embedded in Oracle database is through native image. So the way I understand it, native image was used to build a shared library of this kind of execution engine, and then it was embedded in Oracle database as a shared library. But it's kind of cool that GraalVM's native image is being used to, embed something like GraalVM in the database. So I think it's very cool.
Should I compare this with, for example, having a stored procedure with SQL in a database and now being able to run any JavaScript code as a part of a query or something? How would this work?
To be honest, I haven't looked at that in a while. I know that you can indeed execute JavaScript code right in there, but in terms of are there any limitations and how does it compare to writing stored procedures? To be honest, I wouldn't know. Yeah. Maybe we should write a new blog post and give an update on how it works at the moment. Maybe there are some limitations, but last time I checked, I think it kind of just worked.
Yeah, well, it's not something I would envision doing, executing JavaScript in an Oracle database, right?
I mean, it sounds a bit crazy, I must say, but also I think it opens possibility to use all those JavaScript tools and like JavaScript itself as a language in a database. But I think it's nice to just have more options and access to more tools.
Especially if you can execute logic really close to the data, right? You don't need to fetch it over network boundaries. So
absolutely.
That sounds interesting. Okay, so before we talk about native images, I think I read there's a community edition and a commercial edition of GraalVM. What are the differences of those? Why would somebody be inclined to go for the commercial edition compared to the community edition?
So there are indeed two editions. One is community edition and it's open source. All our source code is available on GitHub. Anyone can contribute. Anyone is welcome to contribute. And a fun fact, I don't know how to validate that, but somebody said me that GraalVM might be one of the biggest Java open source projects out there because it's indeed huge as a project. So there's the compiler, this language implementation framework, all the language implementations. So I don't know if that's true or not, but sounds pretty cool that it might be one of the biggest open source Java projects out there. So that is the community edition. And we have one more. It used to be called Enterprise Edition, but now with the latest release of GraalVM, we have a brand new distribution of GraalVM called Oracle GraalVM. And I guess you can compare it to a commercial edition. So it's available under a free license, meaning you can use all the features that are in that edition for development, for production, basically all kinds of things, for free under this new license. And the differences between those editions are, well, a license, right? So one is open source and another one is this GFTC license. But also there are features that are available in Oracle GraalVM that are not available in community. And the features, I think the most interesting of them at least, are around performance, and more specifically performance in native image. So in native image, you now get access to profile guided optimizations, and maybe we can stop on that when we talk about native image in more detail. You get G1, GC in native image, and going back to this JDK JET use case, outside of native image, it can also be interesting for users because the compiler itself has more optimization phases in this kind of commercial edition. So even if you're running on a JET JDK, you might see more performance, hopefully, with this edition.
Okay. Well, let's talk about native images. The first time I heard about this was, I think, about 5 years ago.
Wow, was it from Oleg or Thomas? Or
yeah, probably. Yeah.
Okay.
And then, what I basically learned then is you can take a piece of Java code, perform some magic compilation on it to some target platform, and then there's a native binary that runs on this target platform, right? So what is native image compilation, and why should anyone want to do it?
Yeah, it's very interesting, and to be honest, the first time I read about it, my mind was blown that something like that is even possible, right? Because we all know that Java is so dynamic, and it's so powerful because it's so dynamic. So how do you compile something like Java ahead of time? Because it certainly poses certain limitations, because if you're doing things ahead of time, you need to know everything in advance. So before I go into this idea behind native image, maybe I should explain how it works at all. So when you run a native image build command and give it your application, what happens is that native image looks at your application starting from its main entry point, and it's trying to find all the code that is reachable. So all the code that will actually be executed when your application runs, it tries to find all of that code, and that includes your application code, JDK classes, your dependencies, everything. And it's looking for all the reachable code so that it can include only that reachable code in the produced executable and then eliminate everything else. So only the things that you actually need at runtime, only the things that are needed for your application to do what it's supposed to do, only those things will be included in this executable. So that is one part of the native image story. And another one, as it's doing so, it's also preparing heap for you. So you can start with pre-populated heap and don't spend time working with that heap when your application actually starts. But since we're doing all of this ahead of time, it has to happen under a closed world assumption. So everything there is to know about your application needs to be known ahead of time when we are actually building your application, because otherwise we just cannot perform this ahead of time compilation. Because we are compiling things ahead of time, and also we are eliminating all of this code loading and execution and profiling infrastructure from your application, so that in the end, it's only machine code and only the things that are needed for your application to run, plus tiny, slim VM implementation, but it's not a full-blown code execution infrastructure anymore. And that is so that your application is more lightweight and faster to start and scales better and doesn't use as much memory. Yeah. So this closed world assumption poses certain challenges, but another way to look at it is it's a different design decision, and along with challenges, I think it brings some important benefits. So all those startup memory, etc., that native image is famous for, but also some interesting security benefits that maybe we can also talk about more further away.
Sure.
So yeah, ahead of time compilation under closed world assumption.
Yeah, so just to validate that I've understood you correctly, right? So if I'm running on traditional Java code, I'm compiling my Java code to a bytecode, and then I run this bytecode on the virtual machine, and then the just-in-time compilation, translate this bytecode to machine code, runs on my target platform, right? So if I'm building a native image, I'm still compiling, probably still compiling my Java code to bytecode first, right?
Absolutely, and that's the part I'm always, skipping, because for me, compiler, it's always the optimizing compiler. That's my bias because, I work on GraalVM. Yeah. But indeed, you need to provide your application the native image in the form of bytecode. So you need to use JavaC to produce the actual bytecode, because as input, it takes bytecode.
So then the native image compilation process takes the bytecode and then this ahead of time compilation to create a basically machine code for a specific target platform.
Right.
Right. So,
but if I can stop there, because you brought a very interesting point about how JVM actually executes code, right? So just to compare, how is that different from native image? Yep. So the way JVM executes code is that when you run an application, it will need to load all your classes, look at them, start interpreting, start compiling, start collecting profile information. And all of that is very impressive work that it does to get your application to that best peak performance. But it also comes with certain challenges around startup, especially if you have a larger application, right? Because it's a lot of work to be done when JVM starts and needs to warm up and compile your code and understand everything about your application. So over time, when it warms up, it does come to great peak performance, but there is a bit of this overhead that you're paying in the beginning when it has to do all this work. And the idea of native image is to move all of that overhead to build time so that you can build it once, but then start fast as many times as you need, because most likely your application will be started more often than it's built. Yeah. So in my opinion, it kind of makes sense to move all of that to build time and then just start when you actually need to start.
Yeah. But it also sounds difficult, right? Because JIT compilation analyzes code as it runs over time and then tries to optimize this code for how it is run or actually being used. Whereas if you do ahead of time compilation, you don't actually know yet what the use case for this code are going to be, right? So how is it even possible? And how can you get the same, or even better performance compared to analyzing something that's running and then optimizing for the stuff that's running?
That's an excellent question. And the reason why JVM is so powerful is this dynamic code execution, right? So indeed, it looks at the application on the go and it adapts to what the application is doing and what is happening at runtime. And it can adapt on the go. So it can make very aggressive optimizations about your code. And then if those assumptions that it made about your code are no longer valid, it can de-optimize, go back to interpreted, and if it warms up again, go back to compiled. But it has this flexibility to adapt on the go to what your application does, right? And this is really fascinating about JVM, right? So how it goes from interpreted to compiled, and then how it can go back. It's really fascinating. And indeed, native image doesn't have that luxury of adapting on the go or even being aware of what the application does at runtime, but that's by default. So what is very cool about native image is that you can use profile-guided optimizations, and that is optimization that allows you to build an instrumented binary of your app, then run it applying relevant workloads so that native image can look at your app, see what it does, collect this profile information, and then when you're building, again, a native executable of your app, you can use this profile information to kind of get insight into the future, so into what your app will actually do at runtime, and build an application with those profiles in mind.
So you're basically using runtime profiling information to feed into your ahead-of-time compilation to make it smarter and give it more context on.
And I think it's pretty cool because in a way you get best of the both worlds. So you can optimize your application ahead of time. You don't need to spend time on that and runtime, but also you get insight and understanding into runtime behavior of your app. So I think that's pretty cool.
Yeah. So with AOT, you're basically moving whatever the JIT is doing on a JVM to compile time, right? So your compilation will take longer, but in the end, the startup time probably and maybe even runtime will take shorter. So what are typical benefits of why should I want to run my Java app as a native image? Like resource usage or performance or startup time? Why should I want to do it?
So the first benefit people usually bring up is startup time because it's indeed much faster on native image. So it again depends a lot on the app you have, but I don't know, out of the demos that, for example, I'm showing, like I would say that an average web server application, doesn't matter which framework, I would say starts about maybe 400 milliseconds on my machine, maybe 200 milliseconds. And then as a native image, it starts in, 30, 40 milliseconds. So it's order of magnitude faster. And it's indeed impressive because we don't have to do any of those operations anymore at runtime, right? We are just loading native executable. It has all the data. It can go immediately do whatever it is supposed to do. So that is startup time, and it's indeed really great, especially for, microservices and serverless application, things like that. So that's one big benefit. I think everyone always brings that one first. But I would argue startup time is great, but I would maybe care a bit more about resources usage, especially again, if I'm deploying to the cloud and I'm paying for all those resources, so CPU, memory, etc., that I'm using. So if I can do the same thing, have the app do the same thing, but use less resources, that probably will be preferable because I would pay less, or maybe I can deploy more apps at the memory usage of my previous application.
Yeah.
And that's pretty cool. And I think I recall this demo that Josh Long did. I think it was Davos, Belgium, where he had a Spring Boot app running on the JVM, and then he compiled it to native. And he showed the memory usage of the process, and it went down to, I think, like 100 megabytes probably. And he said, like, who in the room here ever deployed a JVM app that used 1 gig of memory? You know, many people raised their hands. And he said, okay, this shows you that you can deploy 10 such apps for the same memory footprint. How cool is that?
Yeah.
So I would argue maybe that is even more important. So you can either reduce your resources, cloud, infrastructure usage, or maybe you can deploy more apps at the runtime impact of your previous app.
Yeah, so I guess with the startup time only matters if you're in a scale back to zero situation, right? Like serverless or whatever. And when the user needs to wait for the app to start up, obviously then startup time matters. But for a typical enterprise-y app that runs for weeks or months, then the startup time doesn't really matter, I guess.
Probably not that much. Probably indeed more for like microservices and serverless applications.
Yeah.
So yeah.
So if I have a JVM-based application, then I need to have a JRE running on my machine. I need to deploy my code there and then running, and it will start up, start reading my classes, and we'll start doing start the JIT process. Do I still need a JDK on my target machine if I build a native image, or is it all packaged in? How does this work?
So you mean if you want to deploy your application as a native image, do you need a JDK again or not?
Yeah, on the target server I'm deploying to.
No, so the target server doesn't need to have anything at all. So if you are, but you need to, as you mentioned, you need to build for the target platform and architecture, right? So if you have such an opportunity, I don't know, if you're building on a Linux machine and you're deploying to a Linux machine, that machine that you're deploying to doesn't need to have anything because it's a native app in the end, right? So it just runs fully functional on its own. And then there are ways to build native images in a fully static way where all the dependencies are included in this static native
So
image.
you would still need a JDK for building and compiling
but
it.
For developing, you probably would need a JDK anyway.
Yeah, but in the end, since you're going straight to machine code, you can deploy the machine code. Okay, so probably that would save you on some disk space as well.
We talked about startup, we talked about memory. Obviously, packaging size is another benefit, right? But like saving disk space per se, but also scaling, right? So if you want to scale your deployments, that maybe smaller images would also matter to you. And we can probably talk about performance, but that will be, I guess, a big topic. So before we go into that, there's also very interesting security benefits around native image. And I like talking about it because I think people don't talk about it enough, and they are always very surprised when I talk about security in native image, but it's indeed very interesting. So all those things we talked about, native image and the build process and how in a way it can seem limiting, I think it shines in a whole different way when we talk about security, because a native image eliminates all code that you're not using. So let's say you're pulling in tons of dependencies and maybe you're not using them that much, or some dependency looks kind of suspicious to you, but you still want to use like a fraction of it. So native image will eliminate everything you're not using. And that's one way how, it reduces attack surface. And also, for example, some vector attacks around just-in-time code compilation are not possible in native image because there is no longer code compilation happening at all. And also at runtime, you cannot load new classes, you cannot do reflection and serialization unless you specifically enabled it. Yeah. And it can be seen as a limitation, but also you have a bit more like fine-grained control over your app and what it does and what is happening in it. Because if you want to do reflection, you would need to specify it, or this specification needs to be coming from framework, library, etc. But there are no kind of sketchy things happening without you being aware of it. Yeah, so there are also some interesting benefits around security too. Yeah, so you probably won't have any issues regarding to dynamic class loading, reflection, serialization, because, well, it's just not there. Right? Or it's there, but it has been like specifically configured and allowed by you. So you need to enable those things for them to work. So it won't be happening without you being aware. So how about reflection? Let's say I'm dynamically loading some classes in my Java code.
there's probably no dynamic class loader in the native image, right? So how do you do this?
So reflection works in a way that, I mean, there was this huge misconception that GraalVM doesn't support reflection. So hopefully we are past that and everyone knows that it supports reflection, but there are things to be aware of. So there are multiple ways how reflection can happen in native image. If your framework, library, etc. are doing something that has to do with reflection, they would need to provide configuration for native image to tell native image that, hey, we want to use reflection in this and that class. Maybe we want to access, for example, this field. So that has to be specified in a config file that is being fed into native image. And then it can build an app that is aware of that reflection usage and can work with that reflection usage. That is one part of how reflection works in native image. Now, some of kind of more predictable reflection API calls, native image can figure out on its own. So as it's building application, it calls that are a bit more like trivial and predictable and make sense, native image can figure out on its own. So maybe there would be no configuration happening from you at all. It can just make it work. And then the last way how this can work is that we have this tracing agent in native image, and you can run your application on a JVM, and it will do what it is supposed to do. And this tracing agent will look at that and will produce this config for you, so you don't need to produce it manually.
Yeah.
But as a last resort, if you had to produce it manually, maybe you have a smaller app or something, the reflection config is basically a JSON file where you specify in the pre-selected format what and how you want to use reflectively, and native image can build an app that is aware of that.
Yeah, so basically you need to pre-specify whatever you'd like, whatever your code does reflectively.
Yes, because again, closed world assumption, and it gives you all those benefits, but you need to, for all those dynamic Java features, you need to tell native image how you're planning to use them, because otherwise it most likely cannot figure it out automatically under closed world assumption, because runtime hasn't happened yet, basically.
Yeah, sure. Okay, so let's say that I'm now building apps that run on a JVM and I want to go into native images. Can I take any random Java application and boom, create a native image of it and get all those advantages right away?
So it depends. It depends on what your app does, which dependencies it's using, and again, on your usage of those things like reflection, serialization, resources, etc. My recommendation would be is that most likely you're using some kind of framework, and there are many frameworks in the Java ecosystem that are likely supporting native image out of the box. So if you're using something like Spring Boot, Micronaut, Halidon, Quarkus, and that's, I would say, a majority of the apps probably, they have support for native image. So you would just need to check if you are using the version of the framework, for example, that already introduced support for native image, and then things will be significantly easier for you. So that is one part of how you can make it happen. And another part, if you are not using those frameworks, there is also a way to approach using dependencies. And that is that if you want to use some library, and let's say that library is using reflection, then it's tricky for native image, as we established. So you can either provide configuration for reflection in that library yourself, but most likely it's challenging because you're not the maintainer of the library, so maybe you don't know it that well. Yeah. And in that case, it's better if the library is providing configuration for native image within the library itself, kind of embedded. And luckily, we see a lot of that happening right now. So if you go and check many of the libraries, their source code, they already provide configuration for native image for their users, which is very nice. But also we understand that for some libraries, it's maybe a bit more challenging to adopt native image, or they haven't done it yet. So for that, we created this centralized repo on GitHub where library and framework authors, but also just normal native image users can contribute, share, and then reuse all this configuration for native image. And I think it's very cool because it's indeed maybe you're trying to solve reflection for library X, but somebody else already had that challenge, they had it solved. So why not, share this work in our community so we can all benefit from it? Yeah. So we have the centralized repo, and it's also integrated with our Maven and Gradle plugins, and many frameworks picked it up as well. So at the point it works so well that you can, for example, build a native image app. And if you're using those plugins, or if you're using all those frameworks, that config will be picked up automatically, maybe without you being aware of it if you are not looking carefully at the native image build command. So let's say you're using, H2 is not necessary because it provides config, but let's say you're using some library that doesn't provide config, but it is in this repo. So our plugins will pull config from that repo and will produce hopefully a fully functional app.
Yeah.
So that should help.
Sure. Okay. So would you say it's relatively doable to transform a regular Java app into a native image nowadays?
But again, depends on what is a regular app, right?
Sure, yeah. I remember looking into this years ago, and then it was pretty hard, but I imagine
it got better now. I would not say that like every single Java app in the world will compile to native, like as you just take it and compile it. So it might or it might not, it depends. So I would not promise you that every single Java app in the world would compile to native just like that. But if you're starting a new app, like in 2023, and if you're using one of those frameworks, I think I will be optimistic enough to say that it should just work.
Okay, good. So what if somebody is watching wants to get started with GraalVM right away? What are good resources for them to get started with?
Yes, we have a very nice website, graalvm.org. And there you can find basically all the things you need. So we have documentations, we have samples, we have reference manuals for things like native image, etc. So probably that would be a good place to start. And also we have this GraalVM demos repo on GitHub, where you can just go through our demos and build them and run them. So you don't need to create any of that code yourself. If you just want to give GraalVM a try, but you're not ready yet to compile your own application, you can just get our demos from GitHub and compile them and see how that works for you.
Okay, thank you. Well, thanks a lot for your time and your explanations. I have more knowledge now, but also more questions. I think I need to dive in it myself. Well, I hope you learned something in this episode of GOTO Unscripted. So thanks for watching, and maybe see you at the next edition.
Thank you.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.